Today we're going to look at properties of integer exponents. So page 39, one band's streaming video concert to benefit a global charity costs $1 to view. The first day they got 2,187 views. Second day it got about 3 times as many views. Third day it got 3 times as many views as on the second day. If the trend continues, how much money will the band raise on day 7? So if we think about this, the first day was 2,187 views. And then the second day was 3 times that amount. And you can either figure that out or not. Did you figure it out when you did it, Jeffrey?
Yeah.
Okay, what did you get for that part? Or did you write it? You didn't write it down. Okay, that's all right. Okay, so we get that answer. Anybody got that number?
Wait, 3 times 2,000.
Mm-hmm.
I got 6,561.
6,000 what?
561.
Okay. So then we'll take that times 3. Uh,
19,683.
okay, and then we'll take that and multiply that by 3.
Yeah, 5. Oh, you get 59,049.
Okay, and we'll take that number times 3.
And you get $177,147.
Okay, we're getting close. Take that times 3.
It would be 531,441.
And then we'll take that times 3. Okay, so this is one way of working that out. Obviously, if we're using a calculator and we just put times 3, get our answer, times 3. And you guys remember on your calculators, once you get the answer, you can just right away put times 3. It'll say A and S times 3, and instead of having to retype the number. So this is one way of doing the problem. Another way of doing this is thinking about basically, if we did this, we ended up doing multiplying by 3 1, 2, 3, 4, 5, 6 times. And then technically 2,187 is actually 3 to the 7th power if we break that down. Anyway, we cannot go quite to the extreme that they're trying to lead us in the book, but if you multiply by 3 6 times, basically another way of doing this, we did 2,187 and then times 3 to the 6th power. 3 to the 6th power is 3 times 3 times 3 times 3 times 3 times 3. So this would be a quicker way, maybe, less steps involved way that we could actually come up with that answer. Nothing wrong with the other way we did it, just a different approach that involves exponents, which is what we're going to be looking at in this lesson. So that's why I'm mentioning that. Okay, so you can check it out and you should get that same answer doing the problem that way. And to do that exponent, the 3 to the 6th power, what you would do, you do 2,187 times 3, and then to get that 3 to the 6th power, after you do the 3, you're going to do this little caret button, they call it, which is just below the pi button on the left side there, and then 6, and then that will take it to the 6th power. Whatever exponent you want to use, type your base, and then do the little caret, and then type your exponent, and that will give you whatever exponent you want to use. So example 1, the weight of a newborn male caribou is shown on the right. 2 to the 3rd power. Not usually how they'll say that. On average, an adult male caribou weighs up to 2 to the 6th times more than the newborn. How can you determine the average weight of an adult male caribou? Okay, so normally 2 to the 3rd power to the 3rd power means 2 times 2 times 2. Good, which would be 8. Okay, so normally we would just say it weighs 8 pounds, which is similar to what a human is whenever it's born. Obviously a caribou is going to have a lot bigger weight gains here. It's going to be a pretty big animal by the time it's over with. Okay, so rather than doing that though, the book's wanting us to work with exponents. So what we can do, if we look at this, one way of looking at this, 2 to the 3rd power, like we said, 2 times 2 times 2, 2 to the 6th power, we've got 6 factors of 2. And then we can multiply all those together. Rather than multiplying them all together, we might lose track of how many 2's we've typed in. So kind of an easier way of looking at it is we had 3 factors of 2, 6 more factors of 2, gives us a total of 9 factors of 2. So rather than typing in all the 2's, another way of doing that, we could write that just as 2 to the 9th power. And we put that in and get our answer, which is what?
512.
512, okay. So 512 pounds. Okay. Another way of doing this is what we've got over here. Basically, if our bases are the same, we multiply like bases, we can add the exponents together. Okay, not a bad idea, kind of like what we just did a minute ago. Think about 3 factors of 6, and we're multiplying by, 3 factors of 2 multiplying by 6 factors of 2 gives us a total of 9 factors of 2. So a way of saying this, multiplying like bases, we are going to add the exponents and the base stays the same. Just a little quick refresher on how that works. If you've got like 5 to the 2nd power, the 5 is the base, big number is the base, okay? Both start with B's, big number, base, okay? And then this 2 is called our exponent. It's the little birdie that tells us how many bases we need to multiply together. Okay, so on my example here, we've got 4 to the 2nd power times 4 to the 3rd power, and if we multiply those, we're going to add the exponents. So that's going to be like 4 to the 2 plus 3. We've got 2 factors of 4, and we've got 3 more, gives us a total of 5 factors of 4. And depending on the problem, they may ask us just to write our answer using an exponent, and then we would just leave it like that. If they ask us to also evaluate it, then we could type in 4 to the 5th power and get our answer. Okay.
What if we had a negative number?
Our base could possibly be a negative number as well, but if it is, they have to both be the exact same base. So like if I have negative 2 to the 4th power times negative 2 to the 7th power, that would be negative 2 to the 11th power if I add those together, the 4 and the 7. Okay, if one of them's a 2 and one of them's a negative 2, there's a way we can kind of get around it, but what we're doing right now, let's just stick to those bases being exactly the same as each other. Look at the the local zoo welcomed a newborn African elephant that weighed 3 to the 4th kilograms. It is expected that at adulthood, the newborn elephant will weigh approximately 3 to the 4th times as much as its birth weight. What expression represents the expected adult weight of the newborn elephant? So we started 3 to the 4th power, and it says 3 to the 4th times as much, so that means 3 to the 4th times 3 to the 4th. Like we talked about earlier, when you multiply, these bases are the same, the 3's, the big numbers. And so, look at the little birdies here, the exponents telling us we have 4 plus another 4, means we have a total of 8 factors of 3. And then we could actually work that out and get the answer. An expression, technically an expression, if that's all they asked for, an expression could just be 3 to the 4th times 3 to the 4th. They could be a little bit more specific maybe of what they're exactly asking. I would say that's probably good enough with what they're asking me, but again, we want to go a little further and use our idea of the book calls product of powers property, where we can add those exponents together. I'm kind of curious, 3 to the 8th power, just to know what that is. Okay, so 6,561. Now that's kilograms. We don't really use kilograms much here, right? What do we use? Pounds. Okay, so kilogram is 1 kilogram is about 2.2 pounds. So if you took that answer times 2.2, that would tell you how many pounds. Which looks like 14,434.2. Okay. So that's just a little bit heavier than that caribou we talked about earlier. A little bit bigger animal than the caribou was. Example 2 in your book, we are actually going to skip that one just because it doesn't have very many applications for us. The only case that this can work is if our exponents are both the same. It's more valuable for you guys to know about if the bases are the same, that we can add the exponents. So example 2, it's fine, but we don't really need to know what's happening there. Example 3, it says find the power of a power. Mathematical technicality may be better worded as a monomial to a power. Anyway, so we've got 5 squared to the 4th power. Basically what's happening is that we can just rewrite this. If you take something to the 4th power, you're multiplying it by itself 4 times. So 5 squared to the 4th power means 5 squared times 5 squared times 5 squared times 5 squared. And then we can use the rule we talked about earlier. Now we've got the bases the same. We can add those exponents together, and we've got a total of 8 factors of 5. So that would be 5 to the 8th power. Okay? As we do these problems, you guys may notice different ways that we could come up with the answer. My suggestion is just to do it exactly like they did in the book here, rewriting it and then adding the exponents, because it's less rules for you to have to remember. It's only one rule for you to remember instead of 2 rules. It's going to be less confusing. You can do it a different way that's going to get you the answer quicker, but then what I've seen people do that do it that way, then they get confused. Do I do it this way? Do I do it that way? And then they make mistakes. So my suggestion, just exactly like they did on example 3. On this problem, since it said write an equivalent expression, 5 to the 8th power, we're fine to keep it like that. If it said simplify or evaluate, definitely evaluate, we would actually then want to figure out what 5 to the 8th power was. But since it just says write an equivalent expression, 5 to the 8th, we can just be done at that point. Look at example 4. Write an equivalent expression for 6 to the 5th divided by 6 to the 3rd. They've got it written sideways. We can write it as a fraction. Means the same thing. 6 to the 5th power means 6 times 6 times 6 times 6 times 6. 6 cubed. We've got 3 factors of 6. And then basically, since these are being multiplied, we could actually reduce like factors. So we could actually cancel out 3 factors of 6 in the numerator with 3 factors of 6 in the denominator. That leaves us with 2 factors of 6 in the numerator, so 6 times 6, or 6 squared, which it said an equivalent expression again, so 6 squared is fine. If we wanted to, 6 times 6 is 36, would be exactly what our final answer would be. Rather than going through all of that work, there is a simpler way we can do this. So when we did multiplying like bases, we added the exponents. Dividing like bases, then we will subtract the exponents. And basically it's just an idea, you know, those factors canceling out. You know, we had 5 factors in the numerator, 3 in the denominator. 3 of them are going to cancel out. So like on that problem, instead of doing what the book did, we could say 6 to the 5 minus 3, subtract those exponents, and that would be 6 to the 2nd power. Okay, again, it's fine what the book did. If you want to think of the process, if you even want to do it that way, you can. It's just that, you know, for example, if they give me 6 to the 29th power divided by 6 to the 17th power, you may not want to write all those numbers out and cancel all this stuff out. So if we look at the try it, they kind of are recapping both different ways that we did. Maybe if we go to the try it D, since that's what we were just looking at with the dividing part. So if you want to first write this as a fraction, you don't have to, but if that helps you to think about what's happening here. And then you can kind of imagine we've got 9 factors of 8 in the numerator and 3 factors in the denominator. So obviously more in the numerator. How many more? Well, if you subtract, that'll tell you how many more. And that's what that idea is that we just talked about. So subtract, and that would be 8 to the 6th power. And it says write equivalent expression, so we can actually just leave it as 8 to the 6th power. We go back over to part A then. We've got 7 cubed to the 2nd power. Remember, if you are taking something to the 2nd power or squaring it, you're taking it times itself. So best way to do this, probably so we don't get confused, would be to say it's 7 to the 3rd power times 7 to the 3rd power. And then we can use our rule, multiplying like bases. Add the exponents, so if you want to do this step, you can. You got 3 factors of 7, 3 more, so you add those, would be 7 to the 6th power. Not a bad idea really to show the addition there. That way, in case we accidentally add wrong or something, then we can at least show some work of what we did. Part B, 4 to the 5th cubed, 4 to the 5th times 4 to the 5th times 4 to the 5th. And then since we're multiplying, we got 5 factors, another 5 factors, another 5 factors, gives us a total of 15 factors. So 4 to the 15th power. Part C, we are not going to do. That's like that example 2 that we skipped, so don't worry about that. We could do something with that, but this is our main focus, A, B, and D. Key concept, recap some things. Really to simplify things here, one of these, the top right one, I'm crossing out because we skipped that one. The bottom left I'm crossing out so you don't have as many things to remember. 2 things to remember: multiply, add the exponents; dividing like bases, subtract the exponents. Keep it simple. So on page 42, number 2, if you are writing an equivalent expression for 2 to the third times 2 to the fourth, how many times would you write 2 as a factor? So we look at it. The first part, 2 to the third, would have how many factors? 3. 2 to the fourth would have how many factors? And so total of 7. Good. Which again we can get, like we've talked about, adding those exponents. Okay. Technically, if we were working the problem out, actually this would be 2 to the 7th, understand? Okay. The question just was how many times would you write it as a factor? We would write it 7 times as a factor, but 2 to the 7th if we were actually working it out. Okay. Number 3, Kristen wrote 5 to the 8th as an expression equivalent to 5 squared to the 4th power. Her math partner writes 5 to the 6th power. Who's correct? So what we can do, what we talked about, so we don't get confused on rules, we don't have as much to memorize, we can just rewrite this. So 5 to the 2nd, how many times are we going to write that?
4.
4 times. Okay. To the 4th power, we take it times itself 4 times. And then we can, since we're multiplying, we're going to add our exponents. So if you want to write this step out, you can. So if we do this, 2 plus 2 plus 2 plus 2, 8. So 5 to the 8th power should be right. Kristen wrote 5 to the 8th power, so Kristen would be correct. Okay, we'd want to write a sentence about that, but just for time's sake, we'll just say Kristen is correct. So number 5, they want an equivalent expression for that. Again, expression, so we can leave the exponent there. So since we're multiplying like bases, we can add the exponents. We have 12 factors and another 4 factors gives us a total of 16 factors of 7. So equivalent expression, 7 to the 16th power, we can leave it with the exponent with what they're asking for. Number 6, equivalent expression. We've got the little 4 exponent out here. We don't have a base right next to that 4, so we're going to rewrite this thing. 8 squared to the 4th power. To the 4th power, multiply something by itself 4 times. So once we've done that, multiplying, so we can add our exponents together. And that would be 8 to the 8th power. Again, different ways to do that problem, but this way, less for you to remember, less chance of getting confused on what you're doing. And number 8, we've got a division problem. So if you want to rewrite it as a fraction, you can. And dividing, we can subtract the exponents. So if we do that, 9 minus 4 is 5. So 18 to the 5th power. Again, you can think about, we have 9 factors of 18 in the numerator, 4 in the denominator. So, 4 of those can get canceled out, and then that'll leave you with 5 factors of 18 in the numerator. So this gives you an idea of how to work with properties of integer exponents, multiplying like bases and dividing like bases.